Assalamualaikum warahmatullahi wabarakatuh, and good afternoon everyone. So meet you again in our YouTube class, and for today we will have a new chapter, okay, chapter 6. Okay, after we have many parts in chapter 5, finally, okay, we will have a new chapter, okay, for this chapter 6. Okay, what we will going to learn, okay, in this chapter is about central processing unit. Okay, and I know that everyone here know about central processing unit, or its famous name here is CPU. Okay, for the slide we will have two parts, okay, part 1 and part 2. And for the YouTube, okay, I try to give you minimum as I can. Okay, so before we start, okay, CPU in computers, okay, can be considered as similar with our brain. Okay, as human, okay, we have brain to think. And for the laptop or CPU, okay, we have CPU to think. Okay, so this is our intro, okay, for this chapter 6 intro. What we will cover in our chapter 6 is about first is about CPU components, and then after that we will learn about CPU operation, and last but not least we will look at what is instruction set. Okay, so next, okay, we look at our learning objective. For the learning objective, okay, for chapter 6, okay, you should be able to first identify the components of CPU. Okay, and then the second learning objective for this chapter 6 is you should be able to identify basic CPU operations, and last but not least you should be able to explain the structure of instruction sets. Okay, so make sure that you should be able to achieve, okay, this all of listed learning objective here. Okay, as our intro, okay, what is CPU? Okay, CPU is a portion of a computer that fetches and executes instructions. Okay, so in easy words, fetches here means we get. Okay, executes means we do. Okay, and then a portion, okay, a portion of computer. So we have many portion, okay, in computer, and one of the portion is CPU. Okay, other portion maybe memory, okay, maybe bus, okay, and so on. Okay, so if we say it is CPU, it's a kind of computer, okay, a portion of computer, sorry, that get and do instruction. Okay, that's why in this chapter also we will look at instruction set. Okay, because one of the function of CPU to do the instruction. Okay, and beside CPU, okay, we also call this central processing unit as the processor. Okay, processor, not professor, okay. And if you look at the example of CPU, okay, there are many, okay, type of CPU, but here, okay, we are being familiar with these two. Intel or AMD. Okay, and sometime okay power PC also. Okay, this is actually related with Apple processor. Okay, and before this we have until Pentium 4, and right now okay I'm not want to discuss about this okay in detail. Okay, just enough if we know that before this we have Pentium 4, and then right now until Core i7 or i5. Okay, and for the AMD okay for this we have Athlon. Okay, and then right now the famous one for the AMD known as the Ryzen. Okay, and I believe that right now okay your CPU, if your processor or CPU is Athlon AMD, maybe okay for the current laptop or CPU use Ryzen processor. Okay, for the Apple okay for the Apple I'm not I don't want to discuss in detail. Okay, just for your information that it is for Apple. Next we have a graph. Okay, a graph that show that the number of transistor exists in Intel processor. Okay, if you look from the basic 8086 processor, okay, 9078, okay, I'm also not exist at that time. Okay, so from 1978 to approximately 2000 something. Okay, if you can look at the number of transistor starting from 29,000 okay until okay in 2000 something here. Okay, it reached until 300 million. Okay, so if you want to look at what we call as the Moore law. Okay, what this law and this Moore law said that the number of transistor, okay, number of transistor that can be placed approximately double every 2 years. Okay, so each 2 years the number of transistor will be increased double. Okay, so it is up to you if you want to do more research on this. Okay, you can do this. Okay, but don't worry, because it's not I will not ask you okay about this okay number of processor in quiz or test, for example. Okay, when we want to discuss about CPU components, okay, or processor components, okay, you need to understand about these three things. Okay, the first one is about registers, and then we have ALU. Okay, this is arithmetic logic units. Okay, and for the easy words that we say that it is unit for mathematical calculation. Okay, and then we have what we call as the control section. Okay, so this is what we have okay in CPU, in data section of CPU. Registers. Okay, what is registers? Register is high speed memory, and it is located internal to the CPU. Okay, that means that if we have CPU, okay, we have register in the CPU. Okay, and this is very high speed. Okay, high speed memory. Okay, and some register are user visible. Okay, that's mean here, okay, we have a register that visible to user and not visible to user. Okay, maybe it is kind of architecture that been put secret, okay, in the manufacturer or company like the Intel and AMD. Okay, so for the visible, okay, we can use this kind of memory register. Okay, that's mean available to the programmer, okay, via a machine instruction set. That's mean if we are using assembly language, for example, okay, we can use this high speed memory. Okay, that's mean the process of the fetch, okay, or executes become faster. Okay, maybe, okay, maybe in our critical apps, okay, critical apps, okay, that need speed, so we need to use high speed memory instead of secondary memory. Okay, other register are used by only by CPU and for the control purpose. Okay, that's I mean before. Okay, some of the register only used by the CPU, okay, and for the control purpose, and also for the maybe it's become a secret recipe. Okay, secret recipe for the CPU manufacturer. Okay, then in CPU also we have ALU, arithmetic and logic unit. Okay, this is actually a part of processor that performs arithmetic operation. Okay, what is mean by arithmetic operation? Okay, this is more to the mathematical calculation. For example, we have operation of plus, minus. We also have maybe metric. Okay, so this all under the ALU. Okay, beside that, we also have function of logic operation. Okay, for example, logic, okay, as you learned before, okay, we have or, we have and, not. Okay, so this is means by logic operation, and also other related operation. Okay, so this is what we have in ALU. Then in CPU also we have what we call as the control unit. Okay, this is a part of CPU that control CPU operation. Okay, and this part actually control our ALU, okay, our other components. Okay, and control unit also controls movement of data. Okay, movement of data within CPU and exchange of data and control signal across external interface. Okay, so control unit will control, okay, the movement data between CPU and other than CPU. Okay, okay, so if you want to look at the overall, okay, overall CPU components, okay, you will look in this figure. Okay, you can look in this figure. So we have register, we have ALU, okay, and then control unit control the LU and the LU and register here. Okay, so the control unit also will control the transaction, okay, or transaction between CPU, okay, this green color is CPU, okay, and the other interface, okay, other signal. Okay, so this is just actually our abstract view of CPU. Okay, and then beyond, okay, beyond the CPU we have other path section, control section, and so on. Okay, so this is just the abstract view of the CPU. So after we know about the components, Okay, so what actually CPU do? Okay, or what CPU operation? Okay, and what is the function, okay, of the CPU? Okay, so for the general, okay, um, there are a lot of function of CPU. Okay, and in general, CPU execute or run a program which consists of instruction stored in memory. Okay, so by looking at this statement, okay, you know that CPU will run. Okay, we run programs. Okay, before this program, right now, we call it as the apps. Okay, run apps that stored in memory. Okay, so everything that need to be run, okay, will be stored in memory. Okay, how? Okay, how CPU process an instruction? Okay, this is not just one or two instruction. Okay, there are many instruction. So how CPU process this instruction? Okay, CPU process instruction through implementing fetch execute circle. Okay, what this mean by fetch execute circle? Okay, as you can see here. Okay, so just forward this. Okay, so this is what we have. This is what's mean by fetch execute control. Okay, so CPU will start, okay, and then get, okay, the instruction, okay, and then the CPU not just get one. Okay, CPU will get next instruction after he do, or sorry, it's do, okay, the fetch, okay, instruction. Okay, so it is not just a single or straight pass circle. Okay, just, okay, if you can see the keyword here, circle, that's mean CPU will loop, okay, out the instruction, okay, from one to the next until the program or apps finish, okay, run. So what is actually happen in fetch circle? Okay, so processor fetches the instruction from memory. Okay, so the processor will get, okay, the instruction from memory. Okay, a register called as program counter holds the address of instruction to be fetched next. Okay, so we have special register called as the PC. Okay, that hold the address of instruction. Okay, if you still remember, okay, if you have memory, let's say this is our memory. Okay, we refer the memory through the address that we have. Okay, so this PC will when processor get the instruction from memory, we have PC that hold address for the next. Okay, that's why we call it as the circle. Okay, the CPU always increase PC to 1. Okay, that's mean increase PC to 1. That's mean we have next instruction. Okay, in programming also, okay, we have for example x equal to x plus 1. Okay, so this will same thing, okay, same concept. Okay, they will CPU increase PC to 1, so they will get the next fetch. Okay, then instruction is loaded in the register called the instruction register. Okay, so the instruction, okay, is we get, okay, the CPU get the instruction and put in instruction register. Okay, so this is basic, okay, basic what we have in fetch circle. So what we have in execute circle, okay, we just look at the fetch circle, which is this will involve PC and IR. Okay, so what we have in execute circle, okay, the CPU interprets the instruction and perform the required action. Okay, so after we have our instruction in register, okay, CPU will interpret, okay, what kind of instruction, okay, what kind of action to do. Okay, so this action can be categorized under 4 categories. Okay, the first one is about processor memory. Okay, if it is kind of processor memory based, so the data may be transferred from processor to memory or from memory to processor. Okay, if it is kind of processor input output, okay, input output, that means data may be transferred from peripheral devices by transferring between the processor and I/O module. Okay, and then if it is a data processing, okay, if it is kind of data processing, CPU perform some arithmetic logic or operation. Okay, of course this will use our ALU, okay, because it is involved arithmetic and logic, okay, because it is contained in ALU. Okay, and then if it is kind of control, okay, if kind of control, so control means the CPU monitoring the sequence, okay, of the instruction. Okay, if you still remember that we have in what we have increment, okay, just now, okay, x plus 1. Okay, so this is under the control. Okay, after we know about the CPU operation, okay, that involve the circle of fetch and execute, so last part, okay, as you can see to our content, we will discuss about what we call as the instruction set. Okay, what is instruction set? Okay, instruction set is the collection of different instructions that processor can execute. Okay, so that's mean we have each type of a processor have its own instruction set. Okay, for example, maybe, okay, if you have Intel, AMD, okay, the instruction set here may be different each other. Okay, I'm not sure, okay, how different, okay, between the Intel and AMD. Okay, but okay, according to this statement, okay, the collection is different instruction that processor can execute. Okay, so each processor has its own different instruction. Okay, so what is instruction? Okay, instruction is machine instruction, okay, or computer instruction. Okay, instruction also means by the components will be executed by CPU. Okay, so actually when we talk about instruction, okay, it is referring to assembly like programming language. Okay, we will learn assembly in next chapter, but okay, this just a little brief explanation that what you are going to look after this. Okay, when come to the instruction, okay, actually it's similar to what we learn in assembly language. Okay, so this is just the intro, okay, the intro for the instruction set. We will discuss more, okay, on our next slide. Okay, so we know about the instruction set. Okay, here, okay, we look at what we have in machine instruction, okay, or element of machine instruction. Okay, each instruction must contain the information required by CPU for execution, okay, for run. Okay, and of course the CPU must know, okay, the instruction. Okay, so what is the element, okay, in the instruction? Okay, the first element, okay, that we need that CPU need, okay, is what we call as the operation code. Okay, what is our operation code? Okay, we will go detail, okay, after this. Okay, just I want to list down, okay, what the element here. Okay, the first one is operation code or opcode. Okay, we call it opcode after this. And the second one is source operand referent. Okay, source operand. And then we have third result. Okay, result operand reference. And then we have number 4, we have net instruction reference. Okay, so what is meant by operation code? Okay, we look at this slide. Okay, opcode is opcode, okay, specify the operation to be performed. Okay, we call it as the opcode. Okay, and for the source operand referent is about, okay, source is about input. Okay, when result means result derived, okay, from the operation. Okay, and we also can say that result is the destination. Okay, and next operation instruction referent is address of net instruction. Okay, so that's mean we have address, okay, in the fourth part, okay, in our instruction set. Okay, so this is a simple instruction set format. Okay, for example, here we use 4 bits for opcodes. Okay, we have 6 bits for operand reference. We have also 6 bit for the what the last part is result operand. Okay, result reference. So we have double here. Okay, so maybe this result. Okay, and the total, okay, the total bits that used in instruction is 16 bits. Okay, 16 bits. So we look at some of the example of our opcodes. Okay, opcode usually the opcodes are represented by mnemonics, okay, or abbreviation. Okay, so for the add, okay, add, sub, okay, if you look at that, they take from the subtract. Multiplication, mul, divide, div, okay, load, okay, load, load, store, store. Okay, so this is the simple instruction codes that we can refer here. How about source and result operands? Okay, so source and result operand, okay, operand can be in one of this area. Okay, so source and result operand can be in our main or virtual memory. Okay, also can from processor register, and also can come, okay, from IO, input output devices. Okay, so for example, main memory means by RAM. Okay, I believe that all of you know about RAM. Okay, processor register, we just discuss about this. CPU register, okay, register in our CPU. Okay, And then we have IO devices. For example, we have from CD. Okay, right now we have DVD. Before this, we have diskettes. Okay, we also can have from thumb drive. Okay, so this is just the example that we have in IO devices. Here we have an example of instruction. Okay, very general instruction. Okay, for example, we have add R Y. Okay, what's mean by this instruction? Okay, that's mean that we have we need to add value contained in data location Y to the content register R. Okay, because both of this part, okay, refer to address, right? Okay, address, not at. Okay, address. Okay, so what we do here, okay, we add what we have in Y, okay, plus what we have in R. Okay. Okay, next we have what possible type of instruction set that we can have. Okay, the first type of instruction set, first type of instruction type. Okay, the first one is what we call as the data processing. Okay, so when it's data processing, that means it involves arithmetic and logic operation. Okay, that means we want to manipulate data. Okay, and the second one is type of data storage. Okay, that means when it's data storage, that means it's referred to memory instruction. Okay, that means here we have we keep data where. Okay, and then we have data movement instruction type. Okay, that means we change data location. Okay, maybe if we need fast process, okay, fast run, okay, maybe we need to change our data to register. Okay, so that's the example. And then the fourth one, type of instruction including control. Okay, that means we change the flow, okay, of the instruction, okay, of the sequence of instruction. Okay, for example, if statement if, okay, for, okay, so this is all under the control. Okay, to test and branch instruction. Okay, we divert, okay, instruction to another. Okay, case, we have many, okay, for the control. We also need to know that for the instruction set, it depends on how many address instruction that we use. Okay, number of address, maybe it is 2, maybe it's 3, maybe it's 1, or without address instruction. Okay, so we will discuss, okay, about the 3210 addresses, okay, address instruction, okay, after this. Okay, we look first at the 3 address instruction. Okay, both operand, okay, and the destination for the result are explicitly contained in the instruction word. Okay, so what is meant by instruction word? Okay, this is what that's mean that this is what exactly we write on screen. Okay, instruction word. Okay, for example, x equal to y plus z. Okay, and with the memory speed, okay, approaching speed of processor. Okay, because maybe before this, okay, the memory speed is not fast as processor, okay, so that we need to store our instruction into register, okay, and then take from register, okay. But okay, because our memory right now, okay, is most faster, okay, similar to the processor, okay, so this, okay, give the high degree, okay, of flexibility of the compiler, okay. So we can do this, okay. Before this, if you want to do this directly, okay, on the assembly language, for example, it's not this is difficult to do, okay, because, okay, if you can see here, the format is rare used to due to the length of address themselves and the resulting length of the instruction words, okay. If you use the 3 address instruction, okay, it is something that use memory a lot, okay. Okay, then 2 address instruction, okay. For the 2 address instruction, one of the address is used to specify both an operand and the result location, okay. For example, okay, if you use x equal to x plus y, that's mean we have 2 address instruction, okay. And this is actually instruction that been used commonly in instruction sets, okay. 2 address instruction, okay. Then we have 1 address instruction, okay. That means that 2 addresses are implied in the instruction, okay. For example, here what can you see that by using traditional accumulator based operation, okay, that's mean we just only have 1 address here, okay, and this accumulate in the ACC, okay. Maybe ACC can be register, okay, or memory, and the result from this operation, okay, put under 1 address, okay. Last but not least, we have 0 address instruction, okay. All addresses are implied as in register based operation, okay. For example, transfer register B to A, okay. And we also can refer to what we call as the stack based operation, okay. You will learn about the stack in data, I'm not sure which class, okay, about the stack, okay. You will learn about stack, okay. And stack based operation means that all operation are on the use of stack in the memory to store operands, okay. How can we handle this stack, okay? Through push and pop operation, okay. So when we push, when we pop, okay, this not involve address instruction, okay, because it is based on a stack, okay. Let's say we have this statement or equation, okay. How can we explain in 1 address, 2 address, or 3 address, okay. How about 0 address, okay. 0 address, no, because as I mentioned before, 0 address for the stack, okay. So we cannot show, okay, in this statement, okay, because it is something else, okay, actually. So I think this is a very good slide, okay, to show you the difference between 1, 2, and 3 address, okay. We actually this 1, 2, 3 address use the same statement that we have here, a minus b divided by c plus d multiply with E. Okay, so if it is in one address, okay, if you can look here, that means we only have one address. Okay, so what we do, okay, we need to load D first. Okay, load D and then multiple with E. Okay, and then we add with C here, and then we store in Y. Okay, so what we have here stored in memory Y. Okay, then we continue with load A. Okay, we have A, we subtract with B. Okay, and then we divide with what we have in Y. Okay, Y we have C plus D multiple with E, right? Okay, so we just directly and we store Y. Okay, this is where we use one address. How about two addresses? Okay, by having two addresses, okay, first we move A, okay, to Y. Okay, so we move A to Y. Okay, and then we subtract. Okay, so we solve this first. Okay, Y, move Y, A to Y, and then we subtract what we have in Y. Okay, so this means by A minus B. Okay, and then we move D, okay, to T. Okay, so T is memory. Okay, T, and then multiply with E. So E, okay, E we will multiply with what we have in T, memory T. Okay, and then we add with C. Okay, we add in T, so we add C this. Okay, and then we divide Y and T. Okay, so this is when we have two addresses. Okay, and then when we have three addresses, okay, what we can do, we just have Y. Okay, we have Y, and then we just subtract with A minus B. Okay, and put in Y. Okay, and then we multiply. Okay, multiply D and E. Okay, then we have multiply D and E. Okay, DE, and then we add with C. Okay, and then put in T. Okay, and then we divide what we have. Okay, we have T and Y. Okay, so this is how we use three addresses. Okay, so I hope you also can look what is different, okay, between 1, 2 and 3 addresses. Okay, okay, from what we have before, what can we conclude? Okay, what we can conclude, fewer addresses in the instruction set, fewer addresses in the instruction result in when we have less address. Okay, for example, we have 3 to 1 addresses, one address, okay, in the instruction. What we can see here, we can have more primitive instruction. Okay, if you don't believe, okay, you cannot go back here. More primitive means, okay, you can look at our first one address. Okay, so we have for example instruction of load, then we have multiplication, so store. Okay, primitive. Okay, something that old fashioned. Okay, old fashioned primitive. And then when we have just use one address, so the instruction become less complex. Okay, and CPU, okay, very happy to have one address. Okay, because why? Because CPU just can do words one by one. Okay, and next, okay, when we have 3 to 1 address, what you can see, okay, you can refer your slide, the instruction with shorter length. Okay, if you can see here, okay, in address 1 we just have load D. Okay, but in 3 addresses we have sub Y, A, B. Okay, and for the 3 to 1 address, more total instruction in program. Okay, so what we can see here, the one address will be have one long instruction. Okay, many, that means we have many instruction in a program. Okay, so longer, more complex program. Okay, so when we have 3, it's become more complex. Okay, complex program, that means CPU doesn't like this. Okay, and for the longer, okay, if you have 3, that means execute times for the 3 addresses will be more. Okay, time, okay, compared to 1 address. Okay, so this is actually related to what we have in our previous slide. Okay, so that's all for our chapter 6 part 1. So thank you very much, thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.